Welcome to the setup tutorial for the Micro-Epsilon white light interferometer. This video explains the basic interferometer structure and how to set up the system. The IMS is an innovative white light interferometer. It is available either for absolute distance measurements or for thickness measurements. The system consists of a controller, a fiber optic cable and a distance or thickness sensor. In addition, a voltage source and an Ethernet patch cable are required for parameter setting. Depending on the desired signal output, you will require additional cables. For measurements in a vacuum feed-through, vacuum-compatible cables and sensors are available. Depending on the type of system, the measuring range of the sensor is defined differently. The measuring range of the DS19 distance sensor, for example, starts at approximately 19 mm and is 2.1 mm large. To obtain valid measurement values, the measuring object must therefore be located at a distance of 19 to 21.1 mm from the sensor. In addition, the surface must be optically dense in the wavelength range around 840 nanometers. With the TH45 thickness sensor, the measuring object must be located within the working distance of 45 ± 3.5 mm. This results in a working range of 7 mm, where the measuring object can move freely. The thickness measuring range is 50 micrometers to 2.1 mm at a refractive index of 1, so the maximum measurable thickness of an air gap is 2.1 mm. Depending on the refractive index of the material to be measured, the measuring range may vary. For glass with a refractive index of 1.5, thickness between 35 micrometers and 1.4 mm can be measured. The great advantage of a thickness measuring system is the measuring object can be located at any position within the working range. In order to achieve optimum measurement results, the sensor must be aligned as perpendicular as possible to the measuring object. You can find the technical data for your sensor in the datasheet and the operating instructions. To access the device and to output measurement values, first connect the sensor and the controller with the fiber optic cable included. To turn on the controller, connect a 24-volt direct current voltage source. Use the terminal block for this. For power supply, we recommend the PS2020 power supply unit. To access the sensor web interface, connect the controller to a network-compatible display device, such as a computer or controller, using an Ethernet patch cable. You can now connect the device. To do so, open the Sensor Tool program from Micro-Epsilon, which is freely available on our website. Select the product group and your system and then search for devices. Connected devices are listed as search results. You can now connect the device using the Open Web Page button. You can also connect the device without the sensor tool. To do so, open an internet browser, we recommend Firefox or Google Chrome, and enter the following IP address: 169.254.168.150. Once you have confirmed your input with Enter, the controller is connected and the browser displays the interface. After the start page of the web interface has opened, you can select a preset that suits your measuring task or measuring object. The predefined settings allow you to quickly achieve the optimum measurement result. Selecting a sensor is not always necessary, as only one thickness sensor or one distance sensor is pre-calibrated depending on the system. To set up the measuring range, switch to the measuring chart. If you are using a distance measuring system, we recommend you to place the sensor a little further away from the object to be measured. Move the sensor towards the measuring object. The FFT signal moves from left to right. As soon as you reach the measuring range, the peak moves from right to left. When you exceed the start of the measuring range, the signal reverses again. If you move the sensor away from the measuring object again, the direction is reversed. Micro-Epsilon's white light interferometers also offer a visual positioning aid in the form of a pilot laser on the sensor and the range indicator LED on the controller. If there is no target in the measuring range, the pilot laser constantly flashes and the indicator LED lights up red. As soon as the measuring object reaches the measuring range, the pilot laser lights up constantly and the indicator LED turns green. With the thickness measuring system, this is already pre-configured for the thickness sensor. You can therefore proceed directly to the next step and select the desired object material or the refractive index of the material. You can also use the predefined presets of the thickness measuring system. The web interface contains a material table, which you can also use to enter a specific refractive index. Switch to the measurement chart and move the sensor towards the measuring object. As soon as a peak appears, the sensor is in the working range. As long as the measuring object is within the working range, the peak remains at its position. Moving the measuring object up and down only changes the peak height. As long as a measuring object is completely within the working range, a thickness signal is output. The thickness value remains constant a few nanometers over the entire working range, regardless of the distance. You can see here again that the peak height changes if the distance changes. When, on the other hand, the actual thickness of the measuring object changes, the peak in the frequency signal also moves and changes its position. You can save changes in the measurement settings as setup and then load these as default settings via the favorite selection with the next system start. For this purpose, at least one measurement setting, for example the measuring rate or averaging, must have been changed. First, save the measurement setting as an individual setup. The stored setup is then automatically activated and displayed as a selection in the measurement configurations. To change the stored IP address of the device, you must first enter and confirm your desired IP address. Then refresh the page with the new IP address. To save the new IP address permanently, save it in the system settings. Only then will the website open automatically under the new IP address. With these settings, you can now perform measurements with the white light interferometer.